I have to graph y equals 4. I have to graph y equals negative 2x plus 2. I have to graph y equals square root x minus 2 minus 2. Y equals 4, I go to y value 4, and then I draw a horizontal line through that. Hoi. I go to positive 2, 1, 2, positive 2. Then I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, up 2, left 1. I'm going to connect the dots. Have a vertex at 2, negative 2, right 2, down 2. I'm going to implement 1, 3, 5. From there I go up 1 over 1, up 1 over 1, 2, 3. Now I'm going to do the domain restrictions. Let me get rid of these so I can write down my domain restrictions. My domain restriction for the first one is x is less than negative 1. For the second one is x is between negative 1 and 2. My third one is x is greater than 2. So I go to x value, negative 1, nothing there. I go up to the graph and circle that. I do not fill it in. There's no line under it. The arrow points to the left, so I'm going to shade it to the left. I'm going to copy this picture down over on my original graph. So I go negative 1, positive 4. Negative 1, positive 4, open circle, arrow pointing to the left. For this one, I go to negative 1. Nothing there. I go up to the graph, circle it. No line underneath, I leave it open. I go to x value 2. Nothing there. I go down to the graph, I circle it. No bar underneath, so I leave it open. X is between the two numbers, so I connect the dots between the two numbers. Let me transfer this picture up to this original graph. I go left 1, up 4. I go left 1, up 4. It is an open circle. That does not get shaded in. That is open. Then I go to 2, negative 2, open circle. 2, negative 2, open circle. My slope is negative 2 over 1. I go down 2 over 1, down 2 over 1, connect the dots. X is greater than 2. I go right 2, nothing there. I go down to the graph, open circle. There's nothing underneath of that, so I don't fill in the circle. Now, the arrow is pointing to the right, so I shade it to the right. So here it comes from there. I'm going to go up 1, up 1, over 3, out route, open circle. Unremovable. Discontinuity. I'm going to graph y equals 1. I'm going to graph y equals 2. I'm going to graph y equals 3. All horizontal lines, y equals 1. Y equals 2. Y equals 3. Domain restriction, x is between 1 and 2. Notice I have a line underneath this one, but no line underneath that one. So I go to x value 1. Ooh, that should be negative 1. Nah. 1. Open circle. Fill it in. 2. Open circle. Don't fill it in. Connect the dots between. 2. Up there. Close circle. Has a line under it. It's between 2 and 3. Go to 3. Open circle. No line under it. It's between them. I connect the dots between them. 3 and 4. So I go to 3. Close circle. Has a line under it. Open circle at 4. No line under it. Connect the dots. 1, 1. 1, 1. Close circle. 2, 1. Open circle. Connect the dots. 2, 2. Open circle. 2, 2. Close circle. I'm sorry. 3, 2. Open circle. Connect the dots. 3, 3. 3, 3. Close circle. 4, 3. Open circle. Connect the dots. These are called jump. Discontinuities. 2 jump discontinuities. In order to get from this spot to this spot, I have to jump once. In order to get from this spot to this spot, I have to jump a second time. Have to graph the parabola. The vertex of that parabola is going to be opposite, same. So I go to negative 4, positive 1. Implement 1, 3, 5. From there I go up 1 over 1, up 1, 2, 3 over 1. From there I go up 1 over 1 and I run out of room. I'm going to connect the dots and draw the graph as best as I can. This time I'm going to begin at 1. Go down 2 over 1. Continue to process in the other direction. Connect the dots. This one has a vertex. It's going to start out opposite, same. So 1, 3. Go right 1 up, 1, 2, 3. Implement 1, 3, 5. From there I go up 1 over 1. From there I go up 1 over 1, 2, 3. Out route. Now I'm going to do the domain restrictions. Domain restriction for this first one is x is less than negative 2. Domain restriction for the second one is negative 2 is less than x and x is less than 1. Domain restriction for the radical function is x is greater than or equal to 1. I'm going to go to negative 2 on the x-axis, then up to the curve, open circle, do not fill it in, there's no line under it. The arrow points to the left, I'm going to continue this curve to the left. I go to negative 2, positive 5, negative 2, positive 5, open circle. Then notice I go down 3 over 1, I go down 3 over 1, I go down 1 over 1, then I go up 1 over 1 to get my pretty picture. Domain restriction, I go to x-axis, negative 2, up to the curve, open circle. No line under it. I go to x value 1, go down to the curve, open circle. No line under it. The x is between, so I connect the dots. Over here, x is greater than or equal to 1. I go to 1 on the x-axis, go up to the curve, open circle, but there's a line under it, so I connect the dots. And then it goes out to the right. I have to bring this graph up to this one. Notice I go left 2, up 5, left 2, up 5, open circle though. Right 1, down 1, right 1, down 1, open circle. Then I have to implement the slope, which is negative 2 over 1. I go down 2 over 1, down 2 over 1, down 2 over 1. It lands. I connect the dots. This one I go to 1, 3. I go right 1, up 3, right 1, up 1, 2, 3, close circle. Then I implement 1, 3, 5, up 1 over 1, up 1 over 3, out route. F of x has a removable and a jump discontinuity. Okay, I have to graph each of these. So this first one's going to have a vertex. It's a parabola, so it has a vertex. I'm going to implement opposite same. So the vertex is going to be located at the opposite of positive 3, which is negative 3, and the same as 5. So its vertex is going to be at negative 3, 5. So I go to negative 3, 1, 2, 3, 4, 5. I pop a dot. I'm going to implement 1, 3, 5 for this graph. But I notice I have an annoying negative 2 out in front. So I'm going to bring that negative 2 out in front of the 1, 3, 5. And I have to distribute it. So that means instead of going down up 1 over 1, I'm from this point, I'm going to go down 2 over 1. Then I'm going to go down 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And then I would probably go down 10 over 1, but I don't have enough room for that. I go back to the vertex, go down 2 over 1. I go down 6 over 1. And now I'm going to connect the dots as best as I can. And there we go. I'm going to graph y equals 1 now. That's what that means. So I go up to y-axis 1. It's a horizontal line. This is a hoi. And there it is, y equals 1. The next graph I'm going to graph is the absolute value graph. And that has a vertex at opposite same. And the opposite of negative 3 is positive 3, and the same as positive 3 is positive 3. So I'm going to go right 3, up 3, put my dot. And notice, in front of this, there's a hidden 1 in front of the absolute value symbols. So that means my slope from this point is up 1 over 1, up 1 over 1. Absolute value is of the v, so from there I'm going to go up 1 over 1 and make a v formation. I'm going to connect the dots as best as I can. Now I'm going to implement the domain restrictions on these. So for number 17, the first graph has a domain restriction of x is less than or equal to negative 1. X is less than or equal to negative 1. The next domain restriction is going to be over here for y equals 1, and that's between x equals negative 1 and x is 2. So between x is negative 1 and 2, not inclusive, negative 1 is less than x, and x is less than 2. The final and third domain restriction is going to be x is greater than or equal to 2. I go to negative 1 on the x-axis. There's nothing there. I go down to the graph, circle that. Now I have to determine whether or not I fill that circle in. There's a line underneath the inequality. So yes, I fill that circle in. It's a closed circle. Arrow points to the left, so I'm going to follow the graph to the left. Let me copy this over on the original. So I go to negative 1, 2, 3, closed circle. Then from there, I go up 6 over 1, up 1, 2, 3, 4, 5, 6 over 1 to align with that coordinate. Then from there I go up 2 over 1, up 2 over 1 to align with that coordinate. Now I'm going to come down and do be symmetrical, down 2 over 1, down 6 over 1. The arrow points to the left, so I'm only going to graph the left portion of this. That arrow points to the left forever. The next domain restriction is between x is negative 1. I go to negative 1 on the x-axis. There's nothing there. I go up to the graph. I put an open circle. Now there's no line underneath the inequality, so I leave that circle open. I go to x value 2. Nothing there, so I go up to the graph, I circle that. Notice there's no line underneath the inequality, so I leave that circle open. The x is between the two numbers, so I'm going to shade between the two numbers. So I go to negative 1, 1, negative 1, 1, and place an open circle. I go to 2, 1, 2, 1, place an open circle. And then I connect the dots. Final graph is greater than 2, so I go to 2 on the x-axis, go up to the curve, I circle that. Do I fill that in? Yes, there's a line underneath of it. So I fill that in. The arrow points to the right, so I'm going to continue this graph to the right. I'm going to copy this picture on the original graph. So notice I go to 2, 1, 2, 3, 4. I go to 2, 1, 2, 3, 4. Everybody get on the dance floor. Place that dot, and then from there I go down 1 over 1. Down 1 over 1. Then from there I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Continue the graph to the right. Let me describe the continuity of this graph. Notice, as I'm coming along to graph it, to get from this spot to this spot, I have to lift my pencil. So that is one, jump discontinuity. To get from this spot to this spot, I actually have to jump. Then to get from this spot to this spot, I have to jump again. So f of x has 2 jump discontinuities.